Hello everyone. The last class we finished that how to calculate the electrode potential of an electrode by using the standard electrode of hydrogen, standard hydrogen electrode, right? Okay, so what you know in electrochemistry till now, that we know that what is the cell, how to represent the cell representation we know. Then from the cell representation we can find out the overall reaction of the cell, or vice versa. That means the overall reaction is given and we can represent it in the form of the cell. Then we know that what is electrode potential, okay, and how to find out the electrode potential at the standard condition. Standard condition means what? We know what is standard condition: 298 Kelvin. 298 Kelvin temperature, 1 atmospheric pressure, and 1 molar is the concentration. That's the standard condition. At the standard condition, how to find out the electrode potential? We know that the electrode potential of an electrode cannot be found as such. Okay, so we have to connect it with a standard electrode, and the standard electrode is generally taken as a She, that is a standard hydrogen electrode, whose electrode potential is considered as zero. And by taking it as 0, we can find out the electrode potential of the other one. And the value of the standard electrode potentials are listed in a series called electrochemical series. And one more important thing which you should not forget ever: electrochemical series. And one more important thing that you should not forget ever, that in the cell, whether the reaction at the anode is, we know that is taking place oxidation, and at cathode the reaction taking place is reduction. Now it doesn't matter whether the reaction is taking place oxidation or reduction, the electrode potential of the electrode we are always going to take as the reduction electrode potential. Always we are going to take the reduction electrode potential. What I wrote over here is the standard reduction electrode potential of the electrode Mn, where Mn positive is converted into Mn, that is reduction electrode potential. Okay. Now we know this value of electrode potential at the standard condition, but how to find out the value at non-standard condition? That means we are going to find now the EMF of the cell. We know also this one also, that E0 cell, that is the EMF of the cell at standard condition is nothing but E0 cathode minus E0 anode. E0 cathode, that is electrode potential for the cathode at standard condition, minus electrode potential for the anode at standard condition, and those values we can get very easily from the electrochemical series. Okay, there is no issues over there. But whenever I will tell you to find out the EMF of the cell at non-standard condition, means when these conditions are not fulfilled, obviously then the electrochemical series is not going to help you. That is only giving the value of the standard condition. So non-standard condition, how to find out the value of the E0 cell? Now the question is that non-standard condition means what? The non-standard condition means the temperature might vary, the pressure might vary, or the concentration might vary, or both can vary, or two can vary. In our syllabus, the variation of this is not there. How the EMF of the cell is varying with temperature or pressure, that is not included in our syllabus, and it should not be also. It is much more complicated, so we are not going to study anything about this. We are going to study only that how it is varying with the concentration of the solution. Okay, that is, we are making the non-standard condition by varying the concentration from 1 molar to something else. Okay. So let us just try to know now that how that E cell is found. So obviously E cell, that is that non-standard condition, the EMF of the cell should be equal to E cathode minus E anode. E cathode means what? E cathode means the electrode potential of the cathode at non-standard condition, whatever is the condition. And E anode means what? Electrode potential of the anode at non-standard condition. Now this to find out this value, actually these type of values, that is at non-standard condition, a scientist called Nernst, he did a lot of experiments with a lot of electrolytes, and he finally came to the conclusion of an equation which is known as Nernst equation. So Nernst equation is helping us actually to find out the value of the electrode potential at non-standard condition. Again I am saying that non-standard condition means varying the concentration only. We are neither going to vary the temperature nor the pressure. Okay, fine. That is Nernst equation. Now straight away I will come to the Nernst equation because there is nothing to be deduced and all. And I am going to teach you in the simplest possible way because you know the previous steps. So I am going to teach you the simplest possible way and we are going to do one application of this. Okay, just try to understand this. Okay, suppose in a cell, obviously some reaction is taking place at anode, some reaction is taking place at anode, some reaction is taking place at cathode, and we know what is the overall reaction. What is the overall reaction? We know this. What is the overall reaction that is taking place? Let the overall reaction that is taking place in general, let me write so that you can do it for anyone. Okay. If you know the reaction at anode, if you know the reaction at cathode, you can write down the overall reaction. Let me write down the overall reaction in general. Let me write A moles of A reacts with B moles of B is producing C moles of C and D moles of D. That's the overall reaction, and due to that, during that particular reaction, n number of electrons are involved. That also we can get from this equation. We'll take an example, then you will understand it better. Okay. So this is overall reaction which is happening in the cell. And obviously this is at non-standard condition. Non-standard condition means the concentration of these are not equal to 1. We are only varying the concentration. For that particular case, Nernst equation says that E cell, that is EMF of the cell, should be equal to, that's just derived from Nernst equation. I am writing the final form of the Nernst equation. So it's nothing that it's Nernst equation is done for the electrodes, I am doing for the cells. So same way you can do it for the electrodes and come to the cell, no issues. Okay. So E cell equal to E0 cell minus 2.303 RT by NF log concentration of the products by concentration of the reactants. Concentration of the products, that is concentration C to the power C into concentration D to the power D divided by concentration A to the power A into concentration B to the power B. Once again I am saying this is an experimentally determined equation which determined experimentally 2.303 RT. So obviously that was the ln, that is why it came 2.303 RT log RT by NF log concentration C to the power C into concentration D to the power D, concentration A to the power A into concentration B to the power B. 2 points to be noticed over here. 1. The equation is going or proceeding in the forward direction, that is not reached equilibrium. Then only it is behaving as a cell because it is developing some electrode potential. Okay, and hence some potential difference, EMF of the cell. 2. You must know that what are the states of these reactants and products. Obviously this is in general I had written. So for normal cases, you know that what are the states of reactants and products. Obviously the concentration term, I am talking of concentration terms, will be used only for the only for the aqueous solution. That we know in the previous case. Now, what is what over here? E0 cell means what? E0 cell means nothing but E0 cathode minus E0 anode. You can get these values now if you know that what is the cell which is cathode, which is anode. We can get these values from the electrochemical series and we can write it down. So these values will be given to you. So don't worry about that. It's not that you have to remember these values. So these values will be given to you. Minus 2.303 R. What is R? R in joule is 8.314. So that is nothing but 8.314. The value is constant. T, I told we are not going to vary the temperature. The temperature is remaining as a 298. Temperature is nothing but 298. Divided by N. What is N? N number of electrons are involved in the reaction. Now N number of electrons may vary, right? For certain reaction there is only one electron can be involved, certain reaction there can be two electrons, or in certain reaction there can be 2, 3, okay, whatever number of the electrons are involved, that particular number of electrons. So I am not going to write anything about n because this is a variable quantity. And what is F? All of us know that F is nothing but 96,500 coulomb because we are writing in SI unit. So log of concentration of C to the power C into concentration D to the power D divided by concentration A to the power A into concentration B to the power B. Now one thing I must mention over here, I prefer to write the negative sign over here. Okay, because while writing the negative sign, the concentration of the products is coming in the numerator and concentration of the reactants is coming in the denominator. But in certain books you can find that here the positive sign is written. So if the positive sign is written, obviously the reactants will go in the numerator and the products will come in the denominator. So be careful of that sign also. So that is equal to, again the same thing only, E0 cathode minus E0 anode minus E0 anode minus, now if you calculate this whole thing, 2.303 into 8.314 into 298 divided by 96,500, you are going to get 0.059. Just this value you are going to get. Okay, so final form of this I am writing 0.059 divided by n log of concentration of C to the power C into concentration D to the power D divided by concentration A to the power A into concentration B to the power B. Okay, so this is the value of E cell, and this is a very important equation to find out what? To find out the EMF of the cell at non-standard condition. Again I am saying that the non-standard condition means only that we are varying the concentration that is allowed at our level. Okay. Now we are going to take an example and we are going to use this Nernst equation. You can understand that and you can do it for any cases. Okay. Just try, calculate. Okay, let me write it over here. Calculate E cell calculate E cell for, I'm writing the cell Mg positive 0.001 m double slash Cu2 positive 0.0001 m slash Cu given E0 for, please, two things will be clear over here. Please understand that E0 for Mg2 plus Mg equal to minus 2.36 volt and E0 for Cu2 plus Cu equal to plus 0.34 volt. This is your question. Okay, fine. So we are going to solve this question by using this Nernst equation. Calculate E cell for this by using Nernst equation. Okay, so how to do this? Again I am telling you, I am teaching you the simplest possible process. Okay, and you should follow this process always so that there will be no issues with you with the Nernst equation. Very easy thing to be done. See here what I am going to do, because you know these previous steps which I am going to do. So the cell representation is given to you. The first condition, you see that the concentration of Mg2 positive is certainly not 1. Same way, concentration of Cu2 positive is also certainly not 1. Okay, some other concentrations are given to it, means the cell is at non-standard condition. That's the first thing. So obviously you have to find out E cell. Now how to do that? It's simple again, very simple, very simple. You know the cell representation. What you are going to write? Simply, these are the steps you are going to do. Reaction at anode. Tell me, what is the reaction that is taking place at anode? Mg, obviously this is anode and this is cathode, right? So Mg is converted into Mg2 plus. We are going to write down this Mg minus 2E. We already know this, we had already done a lot of this. Mg2 plus, right? What is the reaction at cathode? Reaction at cathode, that is Cu2 plus 2E is going to produce Cu. So what is the overall reaction? Simple. Whatever I am doing is the one we have to do. Okay. Overall reaction. So what is the overall reaction? In this particular case, the number of electrons is same, so there is no need of multiplication. Suppose in one case there is one electron, in the other case there are two electrons, so you have to adjust the electron, you have to balance the electrons, and then only you have to write out the overall reaction. Okay, be careful of that. Here, since both the cases two electrons are there, so there is no need of balancing, it's already balanced. So what is the overall reaction? Mg plus Cu2 plus producing Mg2 plus Cu, and during that particular reaction two electrons are involved. Yes, suppose there is one electron here, two electrons here, so you have to balance it into 2. Then what is the number of electrons involved? The number of electrons involved is 2. Suppose in one there are 2, one there are 3, so you have to multiply this by 3, you have to multiply the other one by 2, so the total number of electrons in that particular case is 6. Okay, whatever after balancing, whatever is the number of electron, that will be your total number of electron. In this case it's already balanced and 2 electrons are there. That is why the number of electrons involved in this particular reaction is 2 electrons. Fine. So we have got the overall reaction. Now we are going to use the Nernst equation. What is Nernst equation? According to Nernst equation, we know what? E cell, that is what we have to go and find out. E cell equal to E0 cell minus 0.059 divided by n log of concentration of the products by concentration of the reactants, as I wrote minus over here. So what are the products over here? Concentration of Mg2 positive into concentration of Cu into concentration of Cu divided by concentration of Mg into concentration of Cu2 positive. Fine. Now concentration of Cu and concentration of Mg. Obviously, since they are pure solids, the concentration or the active masses, should I say, is considered as 1. So if you don't write these terms also, that is, it is multiplied by 1 and it is also multiplied by 1, because as I told, the concentration means only the aqueous solution's concentration you have to take. Obviously the concentration means we are taking the aqueous solution's concentration only. Now first is E0 cell. Another concept should be very clear. Okay, E0 cell means what? E0 cell means E0 cathode minus E0 anode. So I am going to write it as E0. What is the cathode over here? The cathode is copper. Be very careful of this. What I am writing over here, Cu2 positive Cu. U E0 of Cu2 positive Cu. Fine? Because copper is the cathode. Minus, what is the anode? Magnesium is the anode. I am writing it E0 Mg2 positive slash Mg. See, you have the confusion. Some of you must have the confusion that, sir, why it's written Mg2 plus, but sir, why did you write Mg2 plus Mg? Once again I am saying, yes, in the cell the oxidation is taking place. But again I am saying the same word, the important word, the most important one, doesn't matter whether the oxidation takes place or the reduction takes place. The electrode potential of an electrode, we are always going to take the reduction electrode potential. That is why I wrote down the reduction reaction. Doesn't matter whether oxidation is taking place or not. Yes, oxidation is taking place over here, but we are going to take the reduction electrode potential. That's the convention. Clear? So E0 cell minus 0.059 divided by, what is the value of n in this case? In this case the value of n is 2. Okay, log of concentration of Mg2 plus. See, what is the concentration of Mg2 plus? 0.001 m. Okay, so 0.001 divided by, what is the concentration of Cu2 plus? 0.0001. 0.0001. Okay, fine. So we can calculate this now. What is the value? Just see, we can do it very straight way now. So E cell should be equal to E cell should be equal to E cell should be equal to, now what is the value of E0 cell? E0 copper. What is the value of E0 copper given? If you can remember, we had given it already equal to 0.34 minus E0 magnesium. How much magnesium's value is given? minus 2.36. So it is 0.34 minus of minus 2.36. Is that E0 cell? Minus 0.059 divided by 2 log, how much is this? 0.001 divided by 0.0001. So that's nothing but 10. Yes? So that is equal to, now if you do this, 0.34 plus 2.36, so that will be coming as 2.70 minus 0.059 divided by 2 log 10 is 1, so into 1, so I am not writing that. Okay, so that is equal to 2.70 minus, just divide it, how much it is coming? 0.02. This is 1 and 9, that is 9 to the 18, and 100295. That is equal to how much it is coming? So 7000, right? 50. Okay. 123, 377, then 1176. 2.6705 is it coming like this? 2.6705. That much volt, obviously that much volt is the E cell at the non-standard condition. So hope you understood that Nernst equation and application of Nernst equation, which tells us that how can we find out the value of E cell at non-standard condition by varying the concentration of the electrolyte, not keeping that as 1 molar. Okay, so please solve more numericals related to the Nernst equation which are there in the NCERT. You can solve these, that is more than enough. Okay, so just little bit more part is left in this, so that we are going to do in 2 days, 2 more days maybe. Okay, till then, goodbye, thank you, stay safe, stay healthy.